You know how everyone's suddenly worried about digital identity? Who owns it? Who controls it? Who's selling it? Drummond Reed has been worried about it for 30 years. Co-author, co-editor, co-chair, Pioneer Award, distinguished contributor, Open Wallet Foundation, trust over IP. The man doesn't just sit on boards, he builds them. Please welcome Drummond Reed.
Probably easier to see me up here. Whew, it's very difficult to follow folks that are that brilliant. I'll reassure you, what I'm going to cover here today is a lot easier to understand, but I hope it's a critical piece of the puzzle that we have to solve if we're actually going to have the decentralized systems that Ben and Rafi have talked about, and that Riza preaches, and that's trust. Oh, that's interesting. I pop up right there. So what I'm going to show you, and I'm going to try and do it in just the 20 minutes I'm allocated, is essentially the same talk we gave to the Linux kernel developers at the Linux Foundation Member Summit last week. And Daniela, who's going to moderate our panel, yesterday, she is the executive director of LF Decentralized Trust. That's the home of the Trust over IP project we started almost 6 years ago. And all of these things are coming out of the work we're doing at Trust over IP. So, by the way, if you don't want to take screenshots of the whole thing, take the one screenshot of that and you can get the whole deck. I like to put this right up front. I always love the name Abby Hoffman called that book. So I'll leave that up there long enough. And if you get that one QR code, you can just get the whole deck. It's all online. One of the things that Google helped us with. Okay, so a year ago at the Linux Foundation Member Summit, March of last year, Jim Zemlin surprised us all by opening his keynote by basically devoting the whole thing to this topic. And the reason is that the Linux kernel had been attacked. One of the utilities, it's called the XEU attack, the XEU utils attack. And that's a QR code to go read the Wired story about it. This came within a hair's breadth of being the worst malware attack in the history of the internet. It would have been a backdoor in like 70% of the servers out there, every place on the internet. And it was a Microsoft developer noticed a little funny network activity, and that's how it got discovered before it propagated. So his conclusion was, and this was a talk inspired by the LF Decentralized Trust, that we need decentralized trust systems. And we had introduced something out of Trust over IP and LF Decentralized Trust called First Person Project that's based on decentralized trust graph. So Jim's way of interpreting that was saying, what you're finally doing is taking PGP key signing parties and modernizing them, turning them into something that can actually scale. And he's absolutely right. I'm going to show you that diagram coming up here shortly. Last week, because we were having another workshop to show where we were a year later, we wanted to point out at the start of that problem's actually gotten quite a bit worse. The XEU utils attack was 2 years of social engineering in order for someone to be recognized as a maintainer to be able to inject that malware. The latest example of that with OpenClaw took 2 weeks. And this project, I don't have a QR code there, but you can find that pretty easily. The end of the article about it pointed out that a single agent was able to do 103 pull requests across 95 repositories. And this wasn't a malicious attack. This was an agent instructed to go find open source projects and make contributions that would improve those projects. I can't make any comment on it other than the fact that 5 of those have already been accepted by those projects. The key thing was the maintainers had no way of knowing, was it a person or an agent behind that, okay? A theme we heard at the LF Member Summit, the maintainers of these open source projects are now getting extremely worried that they're going to be overwhelmed with contributions from AI agents. And the only way they can actually make a decision about it is actually have to do the work. So it's sort of a maintainer denial of service problem. Now, the good news is that work on this decentralized trust problem has been going on, and between Trust over IP and the Decentralized Identity Foundation, that both at the Linux Foundation. And specifically, in last September, we launched, in order to meet Jim Zemlin's challenge, the Decentralized Trust Graph Working Group. And what I'm going to do quickly to you is explain what is this, how does it improve on the Web of Trust model that well, anyway, I'm just going to dive right into it. So here's the most important part. There are three basic building blocks. The first one everyone knows, and it is the basic building block of PGP Web of Trust, digital keys, right? So it's the one thing that no matter how smart that AI agent is, unless it can do better than quantum computing, it's not going to be able to break the keys. So the two additional building blocks we have now, the first one, 7 years of my life went into decentralized identifiers. If you're not familiar with them, you can get the book or you can read about it online. It's simply a way of binding a key or a key pairs with a persistent identifier. So it's cryptographically verifiable identifiers. It'll enable you to do key rotation and endpoint rotation. So that you resolve the DID into a DID document the way you resolve a domain name into an IP address, essentially, but with a cryptographically verifiable process. And now you can get the current keys and endpoints associated with anything, a person, organization, a device, an AI agent. With DIDs, and it's not the only thing you need, but the other W3C standard, both of these are now in their second generation W3C standards, are verifiable credentials. They're not complicated. They're simply cryptographically verifiable packages of semantic properties. Yes, you can think of them for people as they will be the digital wallet equivalent of what we have used for a long time to prove our identity, but that's only the tip of the iceberg of what we use VCs for. So with those basic building blocks, we can now go to a problem like the Web of Trust and say, okay, we can actually build a graph of trust relationships. Now, the graph I'm showing you here is the one on the Wikipedia page for the Web of Trust. It's a very simple example of how you build a Web of Trust. The Linux kernel project is so important that if you want to contribute to that project, you must have your keys signed by 2 other members of that. There are 65 members of that Web of Trust that's maintained today, okay? So we're going to take this diagram and say, now how would we turn around and actually turn that into a verifiable Web of Trust? And the first thing we have to do is take those trust relationships and find a way to model them. Now we're going to get to exactly the diagram. We'll step through this, what Jim Zemlin described. How do you do this? Automate the key signing between Alice and Bob. The first part is what we call creating the private channel. And we're going to give the example. Everyone here at this conference, at some point, you're going to show a QR code for, whether it's LinkedIn or Signal or WeChat or Telegram, the quick way to make a connection on. Now imagine you can do a QR code, your wallet to their wallet. It's not on any other network. It's going to be entirely a private connection between the two of you. In this case, Alice shows the QR code to Bob, who says, yeah, I want that connection. His wallet has a key pair, generates we call the DID document, and sends it to Alice at the address in that QR code. She verifies that with the nonce that was in that code, and then she does the same thing to generate and share her DID doc back with Bob. That is now created a unique private channel between the two of them they can use for any kind of communications they want for the rest of their lives, or until either one of them wants to get rid of it. That's step one. Now, having done that, Bob can go down and create what we call a verifiable relationship credential. All it has to be is the key pair and a date stamp, and Bob signs that with his private key and issues that to Alice's agent, who verifies it, and then she will do the same thing for Bob. Sign hers, issue it back. You have now created a cryptographically verifiable relationship between two of them, one of the edges in a decentralized trust graph. So now if we go back to this picture and we said, how would we do this in a way that we can keep it decentralized but make it verifiable? Well, every relationship there has a pair of verifiable relationship credentials, Alice and Bob. So now you can take that whole thing and again, keep it decentralized, doesn't have to sit in a central database, but you can still verify all the relationships. Now, that the problem with scaling the manual web of trust is because all those relationships have to be verifiable someplace. So you have sort of a privacy issue. The Linux kernel, they want everyone to be able to see what all the contributions are. But how many people would take your mobile address book and just put it out on the web, right? Privacy is a big deal there. So, but the second issue is, how do you, to maintain that, the only thing that the Linux kernel has been able to do, and they started this in 2011, is assign a single person to actually maintain that whole thing, that whole web of trust in a GitHub repository. It's a manually maintained. Every new addition, every key change has to be run through that process. And part of the reason is, where's the community? It's just a bunch of peers. With the original PGP model, the only node type you had in the graph was a peer, and every peer had to sign the keys of other peers. So the trust community you could put together could only scale as far as you could get that set of peers to agree. So with what we're doing in the decentralized trust graph, we have 4 node types. Now, obviously we have people, but the second one is devices, and the third one is AI agents, and the most important, I would argue, is verifiable trust communities. Any combination of the rest of those. What you can do now is not just have relationships, verifiable relationships, but you can have verifiable membership. So what we call a VTC, we coined that term because it's any kind of community, from a chat group at one end to a nation state at the other, okay? Corporations, universities, LLCs, you name it. You can model it as a verifiable trust community, VTC. Now here's the really cool thing. If you've got a person as a member, and you have what we call verifiable membership credential, proof of personhood. As long as that trust community can be trusted to issue 1 per person. If you want to understand that concept, it's called a personhood credential. Just Google personhood credentials, and any of your search engines, you go right to the August 19th, 2024 paper that explains the whole thing. But for this group, and what we're talking about here, same thing works for AI agents. You can have a proof of agenthood. And, doesn't show in this diagram, the relationship, the VRC between a person and an agent is now also provable, cryptographically verifiable. So now you can do authenticated delegation to AI agents in a simple and consistent way at any scale across any set of trust communities. And this control comes down to a matter of just having a standard piece of software, whether it's local or it's a web app, where a person is controlling their devices and their agents with a personal network manager, and the set of people that are controlling the agents or a community, they have a control for that too. It's just a matter of, this is how we're actually going to exert this control. So when you go back to this and you say, oh, now we want to model the community, well, there it is. And now you have verifiable membership of everyone in that community. And now I think you can see, you can scale this, and you scale it and you automate it by using what we call verifiable trust agents. I know we're here talking about AI agents. These don't have to be AI agents, they can be. But what they do is they take the manual process that Konstantin Rubayev, I can't pronounce his last name, currently does for that. And he's ecstatic about this. He said, finally, this whole process can be automated. We call them trust task protocols of trust over IP, and that's the next thing we're standardizing. We already have done and so when you have that, if every node, including the community, has a verifiable trust agent, now all of this, and key rotation, adding members, and now, of course, the next thing you're gonna wanna do is connect across communities, and we call those verifiable trust networks. And they can scale exactly the same way the web scales. All it's required is common governance. What we're doing in the first person project is we've created a cooperative called the First Person Cooperative to create a network called the First Person Network, one verifiable trust network for those personhood communities. As they join and everyone says, we'll issue personal credentials to our members, we'll finally have a way to do proof of personhood at global scale in any of these configurations. And I think I got through that in 20 minutes. So just to summarize, what is this? How are we moving from web of trust to decentralized trust graph? One by one. DIDs, not keys. VCs, not just signatures. We can use selective disclosure. Any ZKP experts here, we want to talk to you because the architecture for the ZKP for these is our #1 project right now. And then, as I've said, we can now map verifiable trust relationships, communities, agents, and networks. And we can finally deliver a real trust layer for the internet and for the decentralized solutions that Ben and Rafi have described. And that's the whole thing.
Thank you so much. Time for one question.
Okay,
Anyone?
one question.
One question, anyone? Yes, ma'am.
How would you approach verifiable transactions for nonprofit donations?
Oh, that's a great question.
Great question. I knew there was one. Yes.
So our whole approach we're taking, the First First Cooperative, is literally going and finding market segments that have a compelling need for starting a verifiable trust community. Obviously, the first ones are open source projects because of what's happening in the Linux Foundation. What we're finding is one of the other compelling needs is it is either fundraising or it is basically local currencies. It is saying we need a way to exchange value that we can trust within our project. So if you have a nonprofit and you want to start doing this, please come talk to us. It's cooperatives in general are we are a cooperative, and we're finding many other cooperatives are interested in this. So if you're involved with a cooperative, I want to talk to you as well.
Yeah. So you've done, I think, a magisterial job of establishing trust as a scalable mechanism. Can you speak to curing trust? Because part of human relations is there's the naive trust, which I just hope, and then there's the trust which I've earned as a function of fucking up and curing it.
Yes.
So what is your top of mind, your approach for curing trust?
The powerful part about the decentralized trust graph model is because what you're modeling at the base is just relationships. The only thing you're really saying when you're establishing that relationship is, okay, we know each other. It's not actually a strong signal of trust. We have a second credential type, a very simple but very extensible, called the verifiable endorsement credential. That's how you start to build reputation systems. And reputation systems are, I mean, this whole thing of AI agents and promise theory, and it's just fascinating. I think we will actually start to use AI agents to help us build, find and build trust relationships. That's another one of those things that could go either way. And we are the ones, just to repeat, we need to tip it in the positive direction. So everyone in this room, I'm glad you're here to help us do that.